Okay, thank you very much, Albert. So my plane is leaving in 2.5 hours, so I need to rush a little bit. Sorry for that, but I think we're running a little bit late. Yeah, my name is Thomas. I'm the technical coordinator of Mobile Cloud, and what I will report now in the next, let's say, 20 to 25 minutes is where we are at the moment after 2 years of project lifetime. Okay. What do you want to achieve in Mobile Cloud? This is something that you have to understand from history a little bit. I did my PhD in mobile communications, but then I went to SAP, and SAP is a software company, right? So and then this was also, in SAP I learned about cloud computing, and that is this idea of how can we bring, let's say, mobile communications, my PhD topic, and how can we bring cloud computing, which I did in SAP a lot. How can I bring these two things together? And then this idea of mobile cloud came up, okay? Interesting enough, at that point in time, no one really knew about network function virtualization or something like this. So the whole term and this whole research topic at that time was completely unknown. But basically, exactly that's what we tried to propose at that point in time. When you look at networking research, and that's what at least I learned during my PhD time, is that much is about, or let's say much effort goes into improving the network to reduce cost. When you look in cloud computing, it's a completely different thing. In cloud computing, you try to offer a new functionality, you give new functions, new capabilities to people to make money with new features, right? So when we thought about bringing mobile and cloud computing together, one dimension was to reduce cost, of course, and that's exactly what network function virtualization nowadays is doing. It gives you flexibility, it drives your hardware costs down, maybe it gives you operational advantages, but on the other hand, we were also asking ourselves, can we also add new features? So does this kind of concept of mobile cloud allow telecommunication providers, for instance, or cloud computing providers, which are also part of the stakeholder system, to make money with new features, functions, platforms, whatsoever, okay? So that's why we used to use these two things, these two curves to illustrate what we are aiming at. So, baseline of this idea was looking at the mobile network operators concepts today. So it's the highly static environment. There's no concepts like on-demand, self-service, virtualized, server consolidation, and these kind of things. Many things are built, let's say, engineered dedicatedly for one particular purpose, are very expensive, and so forth. And what we thought with this idea of mobile cloud networking, what we may bring on the table is that we get, let's say, more flexible networks, like based on resource pooling on demand, like all these NIST cloud computing defining principles, right? And at the same time, and that's the other dimension, to also by then maybe able to bundle new service offerings, right? Such that mobile network operators are no longer just providing connectivity, but maybe can also offer services like connectivity, storage, and compute, or maybe even platforms included as a new service offering to their customers. So that's a picture from the proposal. So figuratively, what we try to do is we like to say, like, with what we like to attempt is that we move the concept from cloud computing, which is currently, let's say, confined to data centers and the networks in data center, the storage in data center, and the compute in data center, out of the network and include essentially the access network, or at least the path to the user into the concept of cloud computing. Okay, and that's exactly this, what is illustrated here. And then, of course, if you think this consequently to the very end, it means that you bring all these defining principles on demand, self-service, elasticity, pay as you go, and so forth, which you already know from the data centers where cloud computing has been defined initially, that you also bring that to the mobile network. Baseline assumption was that mobile operators do already have data centers, at least that's what we were told, and that's what also seems to be true from our operators in the network. Not only, let's say, somewhere centrally, but more and more also smaller kind of data center deployments or smaller deployments of racks closer to the end user. Closer to whatever, like the antennas, or at least in some, let's say, more, let's say, urban areas, ultimately closer to the end user. So this, of course, are essentially infrastructures. We call them macro and micro data centers, which we can use to host functions or any other service that we like to offer out of the cloud computing environment. So let's say the scope of the project, and here I think we deviate a little bit from the majority of the talks here, was Not so much focused on the wireless part. We have a wireless part in the project. We do address something that we call wireless as a service or radio access network as a service. But it's just one little task, so to say, in a 15 million euro big project. Okay? So our, let's say, focus of the project was way more on the overall orchestration issues and virtualizing, let's say, the wireless part to some extent, but then in particular the core part, IMS, and also other functions like OSS or BSS functions, like for instance rating, charging, billing, or also AAA in the cloud. Okay? So our idea was what we called always kind of an end-to-end vision. I know it's a bit of an abuse of the end-to-end term, but in end-to-end we mean essentially that you can provision an entire mobile network, radio, core, plus maybe IMS for voice and video, plus OSS management systems, monitoring, rating, charging, billing, SLA system, and so forth, as a whole, in an on-demand self-service fashion for a particular user. Okay? So that's the idea, and that is exactly now this idea of extending the cloud computing principles out of the data center into the mobile network. So there are two scenarios, as I said. One was using the cloud. That's the typical NFV use case. We use the virtual machines provided in a data center to put something on top. But then, of course, in the other dimension, also to extend the cloud, to essentially bring these on-demand self-service principles to the mobile network. Okay, so a little bit of terminology before we move ahead. As you can imagine, if you have people like from SAP, people from Intel, people from, we have Telecom Italia in the project, for instance, or whatsoever. If you bring them in one room and you tell them, hey guys, let's develop services, then you can have a discussion for 3 years what a service means. And indeed, like we spent quite a bit effort in the first 6 months just to clarify terminology. So before I proceed now, I need to tell you a little bit what we mean by what, otherwise you won't understand the slides. Okay, so we agreed on the top level that we have so-called mobile cloud networking services or MCN services. For instance, like a content distribution network as a service, or an EPC, Evolved Packet Core as a service, or a radio access network as a service, or also load balancing as a service. These are the abstract concepts. Then implementations of them, which run, for instance, on top of a few virtual machines, are so-called service instances. Okay, so I can say I have EPC in my service portfolio. If a customer comes, I instantiate an EPC for one customer, so it's a service instance. Then typically, like, for instance, EPC or also IMS or also other components, they themselves are one service, but consists of many components internally. So we call the service instance components. And ultimately, all of this has to run on top of some resources. The most basic resources are compute, storage, and connectivity between these elements. So this is what we agreed on to be what we call resources. Then we had to kind of like come up with a taxonomy. At the highest level, we have the MCN services. You will see in a second what these are. Then we have a number of support services. We also found that, of course, if you want to combine MCN with EPC for provisioning a complete mobile network, then you need composed services. And let's say, for instance, if you consume a resource, a basic resource from a cloud computing provider, then also these things are ultimately a service. So we call them atomic services because you cannot divide a virtual machine into, let's say, more pieces, at least not reasonably. So the services that we then came up in which we have developed, except one. This one is not developed at the moment. The ones that we have developed in the project are in terms of MCN services, radio access network as a service, EPC, IMS, and content distribution. We have an application which sits on top of that. It's called Digital Signage. It's a small, I think it's a former spin-off of Telefonica, Jesus Barrena or something like that. Maybe you know him, Ignacio, I'm not sure. Which is more of a use case and not really a service. Then we have a number of supporting services, load balancing, database, DNS, monitoring, analytics, not implemented, as I said, rating, charging, billing, SLA, and AAA. Okay, and what you can see here already, the idea is to really develop, it's an integrated project, to really focus at, let's say, cloudified mobile networks at large, and not just, let's say, dive into, for instance, a radio access network and go into the very detail of a BBU and whatever performance issues you may have in this domain. And of course, all of this sits on top of the MCN atomic services, and that's compute, storage, and networking. So if the vision is that you bring cloud computing principles to mobile networking or mobile communications, then you have to take the cloud computing defining principles in account. On-demand, self-service, and so forth, as I told you before. For that, what you need is you need to cover the entire spectrum of a service life cycle. Okay? So again, a bit of terminology, took us quite some time to figure that out. But essentially what we say is, from the design of a service, over the implementation, the deployment, to the provisioning, and then the runtime management, down to the termination of a service, our architecture has to be able to cover that, let's say, in the entire service life cycle. Why? Let's just look at the use case. For instance, you come and say, I want to get an EPC plus an IMS as a service. Right? Because you're an MVNO, whatever, of whatever type, and that's the kind of service that you would like to consume. So first, let's say the service was designed, so it's already in the service portfolio, in the service catalog, whatever, in the service repository. Then you request essentially for a deployment. Deployment is this on-demand self-service principle in cloud computing. So you will, in our architecture, you will navigate to a user interface as a service manager with a repository from a certain service provider. And you can request a mobile virtual network on demand. Okay? So you press the button that either you have some pre-configured environment that you want, or you issue essentially the contextualization that you require, and then it will be for you deployed. Deployed means the service will be put on virtual machines, the connectivity in between will be arranged, the storage devices will be there, security, whatever settings and so forth, but it's not yet ready for use. Only when you get the service endpoints back, the management interfaces, the security credentials and so forth, then you can start using it, and that's then moving from provisioning a service, on-demand self-service, to really using a service when it is really provided to you. Okay? That's why we made this difference. Then once the service is there, one of the cloud computing defining principles is elasticity. Okay? So all our services are defined to scale. Now scale is a difficult word. People will kill me for me using the word scale in the project. Okay, let me call it, let's say, grow with your demand and shrink with your demand. Okay, because there's an argumentation whether you say scale horizontally or scale vertically or scale out and scale in. Again, terminological issue. What is behind that is cloud computing. The idea is that your demand defines the amount of resources that you require, and they are provided to you in an automated fashion. That's why we have here what we call one stage in the service life cycle, which is runtime management. And then ultimately, if a user says, so I'm done, I don't need my service anymore, like a typical use case, we saw it this morning, like there's a sports event in a stadium, you deploy a mobile network in this area just for the whatever Olympic Games or for whatever the finals in the whatever Champions League whatsoever. Then you don't need it anymore, so you press a button again, self-service, and the service is disposed. Right? So that's the idea behind mobile cloud. All of this, again, cloud computing principles, rated on a pay-as-you-go matter for you. Okay, so it's a metered service. So that was essentially what we defined and agreed on. That was the mission of the project, and that's then what we tried to implement. So what you can see here, for instance, and that's essentially it represents the stakeholder environment. You can imagine in such an environment you have cloud computing providers, you have infrastructure owners, you have service providers, you have like people came up with ideas of companies that just offer EPC services, others that just offer radio access services. So you have an environment that is extremely complex. Because let's say everyone could just say, I take this out of the architecture and that's going to be my future business model. So we had to define essentially a system that is completely service-oriented, such that really you can almost take any spot out of the architecture and say, that's going to be my future business model. Okay? On the very rough terms, the idea is you have these big MCN services, which can be, of course, combined, for instance, in this horizontal direction for one mobile network service. Those are consuming support services, so load balancing is nowadays what you would call the value-added service in the telco terminology, offered by cloud computing providers. Because cloud computing, classical infrastructure service providers, they have soon realized, pretty much like the telcos, that just offering virtual machines is a commodity business, and you don't make much money with it. Right? So the same way as telcos were looking to add value-added services next to connectivity, you see nowadays like all these infrastructure service providers to trying to add value-added services to their compute, storage, and connectivity business and data center. And things that they offer are, and if you look at the OpenStack environment, for instance, is load balancing, DNS, database as a service, and so forth. Yeah. So we use them, and our, let's say, MCN servers are designed to consume these services as part of, for instance, the offering of a different stakeholder. And then ultimately, of course, there are, let's say, the basic commodity services which any infrastructure service provider offers in public, private, or whatever cloud deployment. So, as I said, let's say the major ambition of the project was this idea that we can provision an end-to-end, it's a bit an abuse of the word, I know, mobile network on demand, okay? So we had this use case, for instance, I live in Switzerland. In Switzerland, mobile virtual network operators are pretty popular, right? And nowadays you see essentially department stores or whatever, grocery stores, whatever utility companies, whatever companies come up, and all of a sudden they become mobile providers. They sell SIMs and they become, let's say, network providers. How do they do that? They go to Swisscom, or to Sunrise, or whatever is in Switzerland. They sign a deal, and then this mobile virtual network is being deployed for them, not in an on-demand fashion, not in a self-service fashion, not in an elastic way, but essentially hardcore engineered for one particular purpose, based on some, let's say, advanced estimation of the users that they might, or coverage that they like to provide. We like to change that. We like to have this idea that you could navigate to a Swisscom, for instance. Swisscom would be a mobile cloud networking provider. They offer you an interface with a service repository, with a set of service offerings in their catalog. And you say, I need this network. I want to have it for the next 3 weeks in the city of Bern, in the city of Genf, Geneva, or in the city of Winterthur, and nowhere else. And I want to have that within 1 day for the next 2 weeks, and I want to be elastic, and I want to be charged in an on-demand fashion. I only want to pay for what I actually have used. Okay? And that's this orchestration challenge that the project is addressing. For that, we had to come up with a number of elements that then take into account different stakeholders and allow you the things. Up front, of course, a service manager. Everyone that offers such a service or a component of such a service, right, has to provide an interface to what we call the enterprise customer. That's our service managers. Then for the services itself, no matter whether it's a support service or an MCN service, you need a technical component which instantiates, deploys, provisions the service, and then also manages it during runtime. That's what we call the service orchestrator. And then ultimately, because this is maybe, let's say the service may be provided by one entity, but it may be sitting on the atomic services from an infrastructure service provider, which is a different business entity. Of course, you need an interface between the service provider's context and the cloud computing product, the infrastructure service provider, cloud provider's context. That's why we have another central component, which is the cloud controller. So in particular, the service orchestrator is a bit of a complex, became a little bit of a complex element. Because as soon as you talk about EPC or IMS or whatever, people will start talking about, where do I place this? I want to be closer to the user. Users have mobility, let's say have a mobility or a mobile nature. I need to be able to react to this. I need to have insight into the physical environment. The connectivity between one side and the other side may be poor. I need to take this into account, okay? So one of the, let's say, mostly also controversially debated elements in our architecture was the service orchestrator. The service orchestrator is there to instantiate the service, deploy it, then provision it essentially, make it available to the end user. Here is service, now you can start contextualizing it, and then ultimately also manage it during runtime. For instance, the whole idea of elasticity, that your EPC instance, right, can grow with the demand, with the amount of users that then in your sports event all of a sudden show up, is essentially handled by the service orchestrator. For that, the service orchestrator has interfaces to mobility as a service, to monitoring as a service, to the SLA framework, also provided as a service, because you if you want to get a mobile network, you also need a whole OSS and BSS environment, and is able to retrieve these metrics and by that scale in and scale out or shrink and increase the amount of resources that you have available for your particular service. The infrastructure graph is essentially a graph that takes into account the physical environment where you are able to deploy your service. For instance, to take geographic or performance-based deployment decisions. You can say, I want to have my mobility management entity at this and this geographic area, or I want to have it in this and this rack, because here is the connectivity much better for whatever, let's say, a contextual element you like to take into account. All right. Okay, I skipped this picture. So if you want to, we can talk about this later a little bit. That's essentially the relationships in UML expressed of all these components. They're generic. It's applicable to all sorts of services. More figuratively here, you can see essentially how all these things fit together. So each service, for instance, Rancher has a service manager and a service orchestrator. Those services are composable via the orchestration framework, and they consume either support services or sit on top of atomic services, ultimately. So it's an integrated project to a very large extent. It was simply bringing lots of technologies together that cover this massive spectrum that we like to address. Just to give you a little bit of an insight, for instance, the project is squarely OpenStack based. So we use OpenStack as the entire virtual, let's say, cloud infrastructure service environment. Nevertheless, we have Cloud Sigma, which is a public cloud computing provider in Switzerland, which is nowadays, let's say, it gets a bit of popularity. It's a company with 40, 50 employees. So we have, let's say, one open source version, and here should be another box of Cloud Sigma. At the beginning, we worked a lot with the standard, let's say, KVM, Xen virtualization environments that come along, but they are not come along, but they are nicely integrated in the OpenStack environment. What we see nowadays, especially in the RAN part, since we have Eurecom in the project, is container-based virtualization, and CoreOS as operating system for that is, of course, massively taking up at the moment. Then for the whole orchestration aspect, first we use Heat. Heat is the essentially integrated components for service orchestration of OpenStack. So we have, let's say, the service orchestrator is squarely based on Heat. It allows you to define Heat templates, and by that complex applications, and provision them and contextualize them, fit them together. And the cloud controller is essentially based on, it sits in OpenShift. OpenShift is a platform as a service environment that comes from Red Hat and is also nicely integrated with OpenStack. For the connectivity between the service instance components, or the services itself, of course, that's something that we had to deal with. And especially the telcos, Portugal Telecom, Orange, we had British Telecom at the beginning in the project, Telecom Italia is there. They were very, let's say, sensitive to the aspect if you have one part of your service, like whatever the MME sitting here in the data center and the packet gateway in somewhere else, that you have to have, let's say, control over the network in between. So SDN, of course, was the tool for that. We work a lot with Open Daylight, which seems to be nowadays not the first selection. And for the monitoring, that was a bit of a controversy. Initially, we used a Silometer, which is the integrated component in OpenStack, but that got dropped because we do not only want to monitor OpenStack, but we also like to monitor all the services on top of it. And for that, Zappix seems to be much more convenient and much better prepared. Okay, here's an example for the monitoring, which is also provided as a service, as I told you, right? The idea is you get an entire mobile network, including the operational and business support services. So here you have the service manager, where the end user could log in, say, I want to get this service. Then a service orchestrator is provisioned for you. The service orchestrator then instantiates the service itself. It exposes a management interface. That's a question whether you like to get a managed service or an unmanaged service. If you request a managed service, it will be configured with the service configuration that is provided in advance, or the service will simply expose a management interface and you will get the access credentials and you can configure the monitoring service the way you like it. Okay, so that's a question of what's the customer's preference. And then, like, depending on the configuration, all the monitoring agents will be started in the services that are supposed to be monitored, like the MME or maybe a virtual machine here or a storage device there. They will be started too, and then respectively contextualized. In other words, they will be configured in a way that it all fits together in one system then. So that was a support service. Now let's look into EPC as a service. So that's, let's say, I think the most attended service in our project. It has an entire work package led by NSC, which is doing nothing else but looking into EPC as a service. So here we started to look really in this idea of virtualization versus cloudification quite a bit. I like to make a point here because many people confuse virtualization with cloudification. So virtualization is, I have a piece of software which runs on an on-premise dedicated piece of hardware. I take it, I'll get the virtual machine, and I put the same piece of software exactly on top of the virtual machine. That's virtualizing. Cloudifying means I take a piece of software, I look which was built, designed, architectured, like the software architecture, for an on-premise solution. I look at it and I think, does it make sense to run that on a virtual machine? Or do I have to re-architect the software architecture in a way that this piece of software makes use of on-demand provisioning, self-service, support service, load balancing, database as a service, cloud storage, whatever. In other words, that it really makes use of the cloud features. And by that, for instance, also becomes reliable. Because before my software didn't have to be reliable because the hardware took over a large part of reliability. Now I move it on a virtual machine which doesn't give me that feature. So I have to re-architect my software. So we make a clear difference between virtualizing something, take it as it is, put it on a virtual machine, and cloudifying something, which is take it, analyze it, re-architect the software architecture such that it makes really use of the cloud principles. So along with this, let's say, discussion, one question was, what do you really virtualize? If you have EPC, do you virtualize, we call that full virtualization, signaling plane and the data plane, or do you virtualize only the data plane and the signaling plane and you leave the data plane as it is for performance reasons, for instance? Okay. Another question is exactly what I was just said. How do you virtualize? Do you put a piece of software, which is a network function, and you just take it as it is and you put it on top of a virtual machine? Or do you re-architect the network function? You take you make it stateless, for instance, for a thing. You use cloud storage, where you keep the storage in behind. By that you can define workers, which you can deploy on demand when your demand raises, or which you can essentially terminate when you don't need them anymore. And since they are stateless and they all work on one storage device, essentially you get the software, it's functionally still the same thing. But from a perspective of scalability, it's an entire different thing, because now with the workers you can scale up and scale down on your particular needs. Okay? So in EPC we have investigated in particular this aspect, where you have a feature which exposes the standard S1 and whatever interfaces, but does nothing else but then really distribute, let's say, the respective work to worker functions in behind, which themselves are stateless and all essentially maintain their state on a storage device and a cloud storage device. And by that we can scale in, scale out according to the load, whatever requirements that someone has. That's the EPC as a service, let's say from a conceptual perspective, same procedure. We have the service manager here, which is the interface to the enterprise end user. We have the service orchestrator in between here, which has information about the infrastructure environment. The request for a new service would come here. The service orchestrator would be deployed for a particular instance, and then the service orchestrator is responsible for deploying, for instance, one service instance for one tenant. Okay. Again, question is managed or unmanaged service. In a managed service, configuration has to be provided in advance. In the unmanaged service, the service orchestrator will expose the management interfaces, and then you can do whatever you want. In the EPC case, we have a particular, let's say, element here is that what we have been told from Telecom Italia, for instance, is that there will be always a network management system. So this idea of exposing the management interface to the end user, and the end user can then kind of configure it, seems not to be the case in the EPC aspect, EPC dimension. I said it before, like for instance for the connectivities in between these elements, which may run in different racks, whatever you want to decide regarding the deployment based on the infrastructure graph here. For the connectivity in between, we need SDN capabilities to manage the network. It's an area where we did not make such, let's say, big advances. We more or less use it as it is and have in particular investigated the aspect of, let's say, when the nodes are in two different data centers and how you federate to SDN controllers. So that's, let's say, again, an illustration attempt how this could look like. Just to give you an idea, let's say what we try to show and what we also have implemented is, try to imagine someone comes over here and says, I want to get a complete mobile virtual network. So let's say we take the purple tenant, wants to get the radio access network as a service, would like to get an EPC as a service, and would like to get an IMS as a service. Right? And this deployed across several infrastructure service providers, based from different service providers. That's what we can show today on our demos. So we can show to provision based on the OpenAir interface from Eurecom, to provision something that is close to a radio access network. As I said, it's not our core domain. We can provision an EPC as a service. We can provision an IMS as a service. The EPC and the IMS, they consume load balancing, DNS, especially IMS and EPC are highly reliant on DNS installations. They use database as a service for the for storing data. For instance, the HSS is based on database as a service. So the HSS becomes a proxy to a database service that runs whatever based on Trove, which is the database as a service from OpenStack. And then, of course, all the support services around, like rating, charging, billing, we have AAA and SLA and so forth. What we can also show is, meanwhile, now after the second year, is elasticity. So by provisioning a monitoring service in behind of that, we can monitor certain metrics. For instance, whatever number of signaling requests or CPU hour or whatever you define. And then if we have, based on this, for instance, EPC, refined EPC architecture, we can scale the system up and down according to the load. Okay. Yeah, just let's say to be complete here is we have this digital signage service, which essentially is our over-the-top use case, and that is exactly this idea at the beginning. We would like to, let's say, evolve the mobile network operator to become a real platform provider, not just connectivity, but really a whole platform, support services, storage, compute for application providers, because we believe this is where the money sits in the future. So digital signage system, you need to imagine, is simply someone that has content here and a number of screens somewhere in the city of Bremen for advertisement purposes or for real-time streaming of events and so forth. That's what they do as a business, as a company in Spain, okay? So what they need is, they need somewhere storage, compute for their backend services where the content sits and is being streamed, and then they have somewhere deployed in a city or whatever, in a stadium, all the screens where they have to stream the media information there. So they need to have some control over the network in between. And that's the perfect use case for us. Before our project, they would have to go to whatever Swisscom and tell them, please give me connectivity for the next, let's say, 10 hours from A to B for this amount of users. And then they would have to go to Amazon, where they sit before, and say and request virtual machines and build their backend application there. Now they could turn to what we believe is the mobile cloud service provider, and would get both, all of this, let's say, a platform for the backend services, for the backend services, storage, compute, plus the network in between, EPC, maybe they need IMS functions whatsoever, part of the radio access, all from one provider in an on-demand self-service fashion. That is exactly what was provided. This without the RAN, so with the EPC, with the, I think CDN was involved, plus the support service is what we showed 2 weeks ago in the review to the European Commission, but it's still a bit sketchy, to be honest, but we still have 1 year to go. Okay, so how does all this relate to NFV? As I said, when we started off, NFV didn't exist. This was like 3 years ago. The project started 2 years ago. So we once failed, so we have resubmitted. So you can imagine we started thinking about all of this something like 5-6 years ago with the first ideas. Okay, at that point in time, no one even thought about network function virtualization or whatsoever. Now, interestingly, if you look in our architecture, service manager, cloud controller, we use a bit of different terminology. But you'll see it's basically very, very close to what NFV has been defining, let's say, Etsy has been defining in parallel to our project, which is a bit of a problem for us because when we started, all of a sudden this NFV thing came up with all these big companies and massive amount of resources, and they were really very, very quick, and we had really a hard time to kind of like keep up with the pace in our environment. So 3-4 more slides, just some lessons learned maybe for the PhD students in the room or whatsoever. So let's say as some food for thought or maybe for some directions whatsoever in the future. First of all, I mean, after, let's say now being 2-3 years in the topic, I more and more become skeptical about SDN. Honestly, I mean, you see people coming up with new whatever dialects, with the next extension of OpenFlow, with the federated cloud controller environment, and all sorts of, let's say, advancements of the tool, but I see no one that uses the tool. If you see what is being used in OpenStack, it's essentially the plugins, so there's SDN plugins for Ryu, for OpenDaylight, whatsoever, they simply translate standard VLAN configurations over SDN, push them to the switches, and that's it. You don't need SDN for this. There has been protocols that do this for many, many years. For instance, now what we have out of this kind of like problem, we thought, what can we use SDN really for? So we are my group with a few others, we are trying to think, why the hell do we not try to improve the aspect of virtualization or virtualization or virtualization? If you look in OpenStack and you have an application that communicates to another application, they may have a GRE tunnel in between. Then essentially the GRE tunnels are translated into VLAN tunnels at the virtual environment. And these VLAN tunnels are then essentially put in VLANs which are set up on the physical environment. So you have GRE in VLAN in VLAN. This is a place where SDN really could make a big difference, but no one is addressing it. So as I said, I see the tool is, let's say, emerging wonderfully, but I don't see really, let's say, cool applications that address really, let's say, legacy issues that we have in the networking space. Then network function virtualization, I've mentioned that. So what to virtualize, also what, I mean, this has been answered for us. I see a lot of, let's say, focus on the classical telco stuff, EPC, IMS, so forth. I think IMS was the first prototype that has been developed in this Etsy environment. But I miss a little bit the supporting an operating system. If you want OSS services, if you want to get a mobile network as a service provided on demand, really cloudified, you not only need IMS or EPC or radio access, you also need, in an on-demand fashion, all the support services around. You need radio charging billing, you need AAA, and I'm not talking about HSS. You need a tool that allows you to authenticate your tenant which requests an EPC as a service. Right? So SLA and. So we have, let's say, an entire work package that does nothing else but just looking in this OSS and BSS, and believe me, that's a really, really complicated matter, far from being easy. Then what I've mentioned before, of course we started off by saying, let's take the network functions as they are and let's put them on a virtual machine. And then all these arguments that this is not reliable and not performant enough and whatever, of course they are true. But then you need to ask yourself, these functions were built, the software, were built to run on hardware which is reliable. Now you moved it on a virtual machine. I mean, this is stupid if you then say the system is not reliable. You need to re-architect your software to cloudify and not virtualize. Okay? So that's something that we are now more and more addressed. So we have a new research topic that we call cloud native applications. Because we realize this is not only a feature in the telco environment. We work a lot with banks. Banks have trading systems. They have whatever dumb systems you can imagine to whatever data warehouses. And they do the same. They just take them, put them on a virtual machine and believe that's cloud. Right? And then they complain this may not be reliable enough. Let's go back to the main frame. So we call that the cloud native application. So in other words, built for failures. You can Google. Netflix is a very successful company that has exactly exercising this in their environment. The whole aspect of elasticity. If you offer something, if you want to cloudify something, but you cannot provide elasticity, then it's nonsense. Because without elasticity, this whole idea of pay as you go which is the economic value proposition of cloud computing, doesn't kick in. So then you don't need to cloudify anything. Then essentially the benefit that you get is a bit of server consolidation, and that's an old topic. So elasticity needs to be built in. Then one thing which we really had a very hard time with is the whole idea of configuration. It's relatively easy if you have the images of an EPC, an MME, packet gateway, and so forth. If you have them ready and you have them contextualized and you have the heat template to provision them. But if you have 6, 7 different tenants, all of them have different contexts, so you need to configure these services in a different way. So now how do you configure these things? Do you inject, and that's what OpenStack for instance does, inject configuration instructions while you boot up a service? But what will you do if you bring in aspects of elasticity or aspects of migration? So a configuration system that is based on text files in the etc directory of your Linux environment is not really very helpful there. So one solution for those people who are aware here is etcd, is a new let's say configuration mechanism that comes up with cloud/Linux. But this whole aspect of configuration management in a very dynamic environment is really, really challenging. Then another thing is this infrastructure service versus platform as a service. To be honest, if I would have to redo mobile cloud, I would not go the regular network function virtualization path, which is based on infrastructure as a service. But I would immediately go to platform as a service. Infrastructure as a service is essentially giving you virtual machines, but you are still responsible to put your service, the whole, let's say, operating system, your platform, your Java environment, your Python environment, whatever, plus the service then on top. But if you're a service provider and you do write software, what you typically would use is a platform as a service. You would say, I don't even bother about virtual machines. I want to go to a provider who gives me already my Java environment, my Python environment, whatever, my continuous integration environment, whatever I need, and I just push my software there. So the whole the network function virtualization discussion should be happening not on the infrastructure as a service level, because it's software at the end, it should happen at the platform as a service level. But that's not the case at the moment. Okay, so these are essentially the major takeaways. Essentially, I put it on slides so that the cloud is not telco challenges, the end-to-end service orchestration, the re-architecture of the functions. By the way, we also had a bit of a hard time to get all of this in this TMF environment, which was brought to us then, of course, the fulfillment, like all this idea of providing a service, deploying it, then managing it, is all defined already in TMF. TMF has assurance processes, has deployment whatsoever. So when you come up with something, I deploy a service, every telco veteran will tell you, but has to be compliant with TMF. So that gave us lots of headache and is, to be frank, not very well solved in the project. Then of course NFV alignment was a big challenge, infrastructure service versus platform service, and ultimately my favorite topic is this whole nonsense of SDN. Okay, so with that, yeah, I'd like to close with a few project details, and I think we have time for 1 or 2 questions.
So you're not only going to miss your plane, but you also destroyed the timing of my session.
Did I?
No, we are fine. We have time for very quick 1 or 2 questions. Yeah.
One question. For instance, when somebody buys this end-to-end service,
yeah.
for instance, EPC as a service you mentioned, then he needs, of course, some support services,
yeah.
and he needs atomic services.
Yeah.
And there are maybe some parameters needed to dimension this
exactly.
atomic service.
Exactly.
And it might be that this, the one who buys this end-to-end service has not the deep knowledge how to dimension this additional service.
Exactly.
You put here some intelligence.
Exactly. And that's exactly what this idea of unmanaged versus managed service. Okay? So you can go, like we had this discussion. So what's the service offering ultimately, as you say, right? So the idea is to say that the majority of services will be managed services. Managed in the sense that you as a customer, most likely, if you move in the cloud, a typical motivation to move in the cloud is to get away from the ICT know-how, right? So it's contra-intuitive to then say, I expose you in management interface and you can configure your service yourself, right? So that's why, let's say, then ultimately we converge to the idea of a managed service. In a managed service, for instance, the one who offers you the service, no matter whether he provides all the service himself or takes support services from a service provider, has the respective business agreements and SLAs in place, and of course has some know-how, maybe based on experience. And you may remember in the service orchestrator there's this infrastructure graph based on real-time measurements of the real environment to offer you the service that you request. Now the idea, of course, is now to say in our service repository, we do not offer you practically a completely generic service. But the idea is that there is, let's say, some services which are a bit of like predefined. That at least the corridor, what you request, fits into a certain pattern that the service provider then can provision the system that he has some, let's say, certainty that he can provide what you actually look for. But again, let's say the idea of course cloud computing is elasticity. So this idea of upfront sizing that you would have nowadays in the networks should at least to some extent be eliminated.
Okay, last question.
So, thanks for this very good talk and nice food for thought, especially in the last few slides. Did you also think about development in mobile cloud networks? So I think about how can you develop components in this framework? How do you develop them? How do you test them? Is there something going on there?
Yeah, what we did, for instance, that's a very good question, thanks for this, is the cloud controller is the central element, that kind of interface between the infrastructure service provider and the services on top, right? And Intel came up, that's why we use OpenShift, with the idea to build an SDK for service orchestrators. Because we thought, look, we should not only focus ourselves on the services that we know nowadays and provide service orchestrator implementations for that, but we should provide an environment where someone can say, and I would like to add another service, support service, atomic service, whatever MCN service to this framework. And for that I need a new service orchestrator. Right? So, and then essentially the cloud controller is built on a platform as a service environment plus respective APIs that is very easy, very easy. It is, let's say, kind of like that you are enabled to come up with and extend new services and build service orchestrators for that. Okay.
Okay, so I think in the interest of time we are going to stop here.
Okay, thanks.
So